Okay, so hello everyone. Let me take a few questions before we start. We still have 3 minutes. Karina, question about lab. Some of the statements returned with the exception thrown are different test cases given that what instructed are asked, which should we match the lab instruction of test cases? Okay, Karina, that's a little bit unfortunate because I thought I have checked every single one to make sure it matches. So here is the rule. You should match whatever is in the test case, right? It doesn't really matter if you change it the other way around. The only constraint is that they should match, right? Because in fact, the exact message wouldn't really matter as far as it's in the same test case. But I would say take it as a rule that you should match whatever is in the test case, okay? AK, aren't we recommended to use try and catch, or are we mandated to not use it? All test cases should match. Okay, so no, AK, you can use try catch if you want, and you are not mandated or recommended against it. It's up to you. There is no problem with that, right? Yes, in the second question about matrix class, can we use all methods defined in the first question matrix class? Well, I'm not sure what you mean by this, but this is a separate class that you are required to write its own methods. You can utilize some of the methods in the total, like in the full matrix class, but well, don't always take this shortcut, right? I mean, you are required to write the method for the upper matrix class in a certain way. If you give me one example, yes, I would be able to recommend, but now the question is a bit generic for me. Kevin, I know you have said before to make a test case for each method, but there is almost 17 methods. I just wanted to clarify that you wanted approximately 17 test cases. Okay, so Kevin, the rule is, well, in best case, yes, that's correct. We need 17 test cases because one test case per method. If you combined multiple methods in the same test case, because, for example, in lab 3, this is how it worked. I don't think in lab 4 in Java, you really need to do this. So I would say yes, please do so. Also, can we write helper methods in either two classes? Yes. As I said, it's really generally recommended. I recommend you that you write your own helper methods if you need so, right? This is a good programming practice to factorize your code. If you think that there is a method that you need to use in multiple other methods, then it's better to define it as a method, right? Not just repeat your code inside different methods. So yes, define your own helper methods if you feel it is going to make your code better factorized. Karina, do you have any hints for the very last question with X? So I guess, Karina, what I remember is we briefly discussed this in the tutorial. To be honest, I'm not sure if I remember. So if you have a specific question, we might send me and I will look into this. But right now, I don't recall on top of my head. Let me think. No, I don't remember, to be honest, what might be a shortcut or a hint that can help you with that. Cham, should we assume each row has the same size number of columns for the upper triangular matrix method? Yes, in the upper triangular matrix method, we even go further and say it's assumed to be a square, right? From the question itself, yeah, as AK is saying, it's assumed to be an n by n matrix, right? So the number of columns and rows are equal. You don't need to consider the case that we discuss in the full matrix class where you can have an upper triangular matrix which is not square. Like in the second class, you assume your class is only considering square matrices. Okay, so yeah, so what we are going to do in this lecture, we are going to continue our discussion for the linked list, but because I thought we have been doing so many theoretical lectures that might be boring for some of you. So what I'm going to do is I'm going to reiterate on some of the concepts we discussed last lecture by hand code this with you. We discuss maybe almost all the concepts back again in single linked list, and then we take it further by looking into doubly linked lists, okay? So I hope all of you are already seeing my online GDB tab. If not, please say in the chat. And simply what we had before here, this is the LL node class that we started with last lecture, yesterday lecture. We said that each node in the linked list has two things. The first one is the value that you store, which is originally the only thing you had in your array, right? And here we are assuming a linked list of ints. That's why the value is int, but generally it can be anything. It's like you can have an array of anything, or any type, I mean. And then we need the second thing, which is new compared to arrays, which is having a link to the second or the next, or what we called the successor node for this node, to be able to construct the chain, right? And we said that this is a reference of the same type, LL node, as you can see here, right? LL node is the same type. Let me see if I can just remove this to make it bigger. Okay, that's good. And what about this? Okay, good. So this LL node is the same, is an object of the same type, because it's going to be a reference to the second node or to the successor node, which is of the same type. And then we also have this constructor where we take two values, the value and the successor or the next link or reference, and then we initialize our value and next. Good. So this was the LL node, which is this is a class that is constructing a single node in the chain, right? As well as its link to the second one. Good. Then we said we can take this class, use what we had a separate lecture for, which is class composition. And we said we're going to build a single linked list out of all these nodes. And we said, as far as you have this LL node class, you really need only a single thing to construct the chain of the linked list, which is only having the address or the reference or the pointer to the first element, right? Which is the head, right? So simply, if we remove all of this, by just having this, you have a linked list. Why that's the case? Because you only need the reference to the first element. Everything afterwards comes with this next, I would say, oracle or miracle link, right? Is there any question in this so far? Can you try to zoom in, please? Okay, I guess. How do we commit changes to Get in Java? It's exactly the same thing, Ishmael. Like Java or C, it's independent of like Get is independent of the language, so it should be exactly the same way. I hope this zooming in is making it better. Okay, so if not, please let me know in the chat. Good. So this is what we discussed last time. That's good. That's perfect. Thanks. Yeah. So what do we do in this SLLL? I guess one purpose of today's application is really also to answer this question. So far, this LL node is not giving you a linked list, right? It's only giving you a class of a node, right? And how to construct a fully linked list? Well, what we said is we only need for the array, if you remember, let's think from what we know, right? What we know is that the array, the only thing you need is the name of the array, which is giving you also a pointer to the first element, correct? It's exactly the same thing here. If you need to construct a linked list, the only thing you need is the address or the reference to the first element, which is the head, right? And then you can traverse the array as we see right now. Good. Okay, good. So let me see if I can just return back what we had. Perfect. And then what I'm doing here is just I'm writing a constructor. Something you can observe here, I'm just ignoring all these specifiers, but you should have it, right? Like public class SLL, and this is also a public method, which is like the constructor, but it's not our focus right now, right? I want to be as generic as I can. So, and I'm writing a constructor for my single linked list to initialize my head reference, right? So which means in the main or in a tester class or another class, I can define or declare and then allocate in the memory a space for my linked list by initializing the head to a certain reference to a node. Good. And then also after this, we took it further and we said you also need the SLL class or the linked list class, because when you write methods that operate on the linked list, remember again, we had one separate lecture about this, how to match the real world with the programming of object-oriented programming, right? So we said for an object in real world, you have two things. You have the attributes and you have the actions. Attributes is simply like the instance variables. Here, we said you define a linked list using, in fact, a single attribute, which is a reference to the first element. But also, the main reason why we define those classes or those objects is really we need to do some operations on, right? And or the actions. And here comes the methods, right? So one method we discussed last time is traverse. We have discussed multiple ways of implementing the traverse in the main or in the tester, inside the LL node or inside the SLL, right? All of this discussion was for purpose of completion, but for now, let's focus on what is the ideal way of doing this, which is all the methods related to the linked list have to be inside the linked list class, right? So this is the right way of doing it. So let's see if I want to traverse a single linked list. What should I do? The first thing is I should declare an index or an iterator to go through the linked list, right? So I need some iterator. One question to you is, what would be the type of this operator? How to define it? I need now a reference that moves across the linked list to traverse it. So what would be the type or how I would define this iterator? What do you think? Any idea? LL node, Sarah, thank you. So I would have to define this as an LL node because it has to reference nodes, right? So it would be LL node, and then let me call it, I don't know, anything, index. Then where should I put this iterator initially? So the first thing is we defined it, but I should start from a certain point. And this point should be, what do you think? The head, Mark, thank you. So here I'm starting from the head, and then I should go through. So I would say while index is not null, then I should continue in my list, right? Why this thing would work? Because we said yesterday is the termination of the linked list, the tail element of the linked list, it's going to point next to null, right? Which is your termination, similar to having a string in C, for example. Good. And then as far as my index is still not null, I can do whatever I want. Like for example, let's say printing. So I would say system.out.print line, and then, well, okay. Let me say I'm going to print index dot, and then I know that this is of type LL node, so I want to print the value, so it should be value, right? Oh, come on. Good. And then this is just anything. You can traverse reading, printing, whatever you would like. It doesn't really matter. But then I should move to this next one. And now the main question is how to move my index or iterator across the list. What should I do? I should advance it. And the way to advance this is to point to next, right? And that's all you need to know. This is how you would traverse a linked list. The first question is why I didn't need to pass anything here, because simply you are already inside the SLL class linked list, and means you already have access to head, right? So you really don't need anything, right? The other question is why I was able to do this index.value, because value in the LL node is really, like generally we said, if you don't have any specifier, you have access to it through the whole project, right? If you write a more strict and better written code, this should be private, and then you have a getter for this, and then you would be using the getter here. Good. Any questions so far for the traverse or all what we discussed until now? It seems easy, right? No? Yes? So one thing to observe is really for a linked list, it's a more of, I would say, a virtual or a hypothetical or something that is more about thinking about the structure rather than knowing new information about the programming language. If you think of all what we have done right now, we really didn't do anything new, right? We didn't introduce any new way for programming in Java. It's just using what we have learned to apply to a certain data structure, right? How do you add values to the list? I understand how you make Arjun. I'm going to come into this, but yeah. So we discussed the traverse. So let's see the second thing we discussed, which is inserting an element to the list. We said one of the easiest ways of inserting to a linked list is to insert at the beginning, because this wouldn't require you to traverse anything, right? And then so index at here is kind of a reference or address of this instance. That's correct, Yan Hao. It's not for this instance, it's for the LL node because you keep moving in the LL node, right? Good. So let's see now I want to insert at the beginning. So I would have a method, let's say called insert at beginning. So it returns void, and then insert at first or at beginning. And then, well, I would need some inputs here, but let's leave this for now. So I would need to insert something, right? So because I'm going to insert a node to the linked list. One thing I would need, so yesterday we really needed two things. The node that I'm going to insert, like the linked list reference and the value, right? But right now we are inside the SLL class, so you don't need, you already have the head, but you still need the value of the node you want to insert, right? So you need int and val, right? And then now, yesterday we discussed multiple steps you need to take in a process way to make sure you can insert in a correct thing. The first thing is, do you remember what would be the first thing I need to do? If I want to insert a node anywhere in the list, not even at the beginning, what is the first step? Create the node itself. Benjamin, thank you so much. That's correct. So no, I would need first to create the actual node and then point head into it and all do the other steps. So it would be LL node, and then what I'm going to call it, new node, then equal new LL node, and then I need to initialize it. So I know that the LL node class takes two values, the value and a pointer to the next. What should be the pointer to the next in this case? What do you think? Any idea? The head, perfect. Because we want to insert at the head. Thanks, Yuland. Yeah, AK, that's correct. So by doing this, we made the LL node point to the head. There is one thing remaining, right? So far, we attached the node to the linked list at the beginning. Perfect. One last step is needed to make sure we have access to this node. Do you remember what is this? Or yeah, update the head, right? Because remember, our only access to the linked list is really this head, right? This has to be up to date. Otherwise, you are losing access to the ones before it. Does head point to the original first value? Yes, always head should be pointing to the first value. And the way to ensure this Arjun is to update it every time you insert something. So in this case, you have to say head equal the new node, right? Good.
Right. So setting the reference of the new node to head is actually referencing the original first value, not head itself, right? Because when you change head, that shouldn't affect the previous, because then it would be referencing itself. No?
Yeah,
so
that's an excellent point. So head is nothing other than a reference to the first node. So which means head is pointing to the first node. So if you make your new node to be the next equal head, then both will be pointing to the original first node. And then later you need to update head to the new node, right? If I want to visualize this, I guess we visualized it yesterday, but it might be good to also revisit this quickly. Let me, I hope this works smoothly. So I guess you should be able to see my whiteboard. So simply, originally I had, I don't know how many elements I had in my linked list. I don't really care. I know that I have the head here. This is my assumption for the insertion at the beginning. What we have done is simply two lines. The first one is creating the new node with the value and making it point to head, because simply saying this equal this, both will be pointing to the same place in memory. Afterwards, the second line is just take this head from here, move it here. Is that clear now?
Right. So saying its reference is head doesn't mean it's referenced to head itself. It references whatever head is referenced.
Yeah, because head, so assigning a reference to another reference. When I say a reference, like an object name, right? Which is like something, the counterpart of a pointer in C, right? So the reference name itself is really nothing, right? It's a variable that is holding an address, right? So saying object, remember previously we said if there are two objects from a certain class, let's say point point 1 and let's say equal new point, we initialize something, then later I come and say point 2 equal point 1, what really happens is that now both will be pointing to a single place in memory, which is originally was point 1, and now it's also is going to be point 2. Right?
Right. So if you reassign P1, it shouldn't affect P2.
Yeah, exactly. Because you are changing B1 to another thing, but you're not changing the memory itself. So that's correct. Yeah.
Okay. Thank you.
Welcome. Okay, perfect. So that's inserting at first. One question you always should ask yourself is there a special case, right? What I mean by this, for example, what would be the case if the linked list is initially null? There are no elements at all, right? Which means the head is null. Would your insert at first would still be correct? Let's think together, right? You always have to ask this question, right? Yes, it would still be correct because I'm making my new node. And then if it's going to be the only single node in the list in this case, and head will be null, so it should point to null, right? Perfect, that's correct. What if then the second special case? The second special case is, what if the linked list originally had a single element? Well, it doesn't really matter, because if it had a single element, head is pointing into it, and then head next is null, then I'm going to insert after or before it and then update it. So I really don't care whether the list has a single element or multiple, right? So you always have to ask these two questions at least. We will have more questions when we come to deletion, but at least ask these two questions about special cases. Is your linked list empty? And is your linked list has like a single element, right? And then the last one would be, what if you are doing something at the last tail, right? But this didn't come yet. Good. Okay, so this is insert at first. Let's take it a step further and write a different insert method that a little bit complicates things. So what I want to do is I want to insert after a certain value, right? After a certain value, which means I need to take a value, search the linked list for it. If I find it, I insert after, right? As we discussed yesterday. So how to do this? I'm going to write a method that I can call insert after value. And then now I need really the value that I want to insert in addition to the target that I'm searching for, right? And then before I can really create my node to point to something, or really I can even do this. Let me show you this standard way of doing stuff. Well, should I do this? Let's do it. So let's say I'm going to initialize my node, create it not connected to the chain, just pointing to null. After I create, so I'm going to call this step 1, which is create the node. But in fact, well, I'm going to change this later, but let's say this would be the step, okay? And then after creating the node, I should search or traverse the linked list with a certain value. So I should really copy some of the code here, having an index that is equal to head, while index is not null. But instead of printing, I should search for the value that I'm looking for. So I should check if index dot value equal to my target. If that's the case, then what should I do? I know that this is the node that I should insert after. So insert after this. I should write the code here. I will come into it, but then and really you will already be done. So right, so you might even break, right? So after you insert, you can just say break because you don't need to keep searching. Well, once you come here, I might also or even return, right? So if I come here outside this while loop, which means I never inserted, that means I didn't find my value. So I did not find target. And in this case, I should do something, right? So this is the block of code. First of all, I traverse the list. I look for my target. If I find it, I should insert and return because I'm done basically with my method. If not, I'm updating my index to be the next one and keep checking. But then once I go out of the loop without returning, means I didn't find my target and I should just do something, right? For example, print the value didn't exist. So let's say I'm going to print something, system dot out dot print line, and I would say target did not exist, something like this, right? So now I'm going to look into questions, but once we complete the method, good. So now let me revisit back. I should insert. So how to insert? Now comes the careful steps we discussed yesterday. So it might be a good time to jump back to the whiteboard. Let's see. Move all of this. See, I have, this is my linked list. Assume now the case that I'm inserting after a value, which is this target. I have my node here that has the value, and I should insert, insert, I'm inserting before or after. Let's say I'm inserting after, if I remember correctly. Yeah, insert after. So what should I do? We said, if I want to insert after, so if I take the target next, make it here such that I make my value after the target, I broke the chain. So that's wrong, right? So then if I'm not doing this, what should I do? What do you think? Save the address of the node after this, Karina. That's perfect. And the way to do it is, first of all, you know that this one should come after your new node. So you can make your new node next equal to this. And then, and only then, make the target next equal the value. This is how you attach a node in between, right? Just make sure you don't break the chain. And that's a very important step to check, right? So going back to the code, now I want to insert after. So the first thing I should do is to say new node dot next, in this case, should equal to index dot next. Now I'm not losing the one that is after, and it's safe right now to update index dot next to be new node. Good? Does this make sense? Well, revisiting what I said earlier, I can really take this and just put it inside here. There's another way of writing it, right? But to be honest, I usually prefer to, first of all, create the node outside and then update the pointers or the links afterwards. Both would be equivalent, that's fine. So before I take questions, or let me first take questions. Could you write while LL node dot value not null instead of index? No, Jack, that's not correct. That's an important question. So you need to differentiate between two things: the value inside the node and the link. The link itself is the one that should be null to indicate the termination. LL node value is an integer value, right? For example, it can hold 0, but while it's not the tail, right? So the value and the link are not attached. I hope this answers your question, Jack. And if anyone else has the same concern, please ask. Karina, save that, okay. Sarah, provide, okay. Yan Hao, let's the new node point to the next. What does that if statement do? Yeah, the if statement is simply searching for the node, find the node you want to, oh, this should be, find the node you want to insert after, right? So simply your target is the one that you want to insert after. Going back to the whiteboard, it's the one, well, let's keep hopping. This is the one that you want to insert after, but you need to find it first, right? So you need to traverse your linked list until you find it, and then you do your insertion process. Good? Jack, oh, so you could write while lnode.next equal null instead. Or maybe I misunderstood. No, you are correct, Jack. So that's also a good question. You can say the next not equal null. It's like saying you are writing a for loop. Should you stop at less than n or less than or equal to n minus 1, right? Here I'm using my index to always advance it if it's not null. But you can say if the index dot next is not null, and then you operate on it. So both would be correct, but it's a slight change, right? Okay, perfect. So then one important question, are we done? No, right? Because I told you, you always have to think when writing any method for any data structure, you have to think of the special cases, right? So what would be the special case here? The first one is, what if I have an empty list, right? In this case, are we considering this by default or no? What do you think? Yes, how? That's correct, because if initially the head is null, this condition will not be satisfied even for the first node, and then you will jump directly to here. So to answer your question, Yanha, what we are comparing is, so the value, this value is the value of the nodes, right? So we keep advancing the index. It's not the value that we want to insert, right? Not the val, right? So this can be 3. No, this can be 3, while this target can be 5, right? They don't, or 3 and 3, it doesn't really matter, right? Okay, so we are considering the empty linked list by default. Good. What about if I want to insert after? What if I want to insert after the head, for example? Are we considering this? Well, I guess yes by default, because the head is also the node you start from. But maybe the more important question, are we considering the case where you insert after the last element? That's important, right? So let me go back to the whiteboard. What if my target is really not that? What if my target is something like that? This is linked list, and this, my target is the last element where it's pointing to null here, right? And then something like this, this is the head, and I find my target here. Are we considering this special case? So let's see what we do. So we create the node, we assign the value, and we want to insert after. What we do is we make, first of all, we make the next of this one equal to the next of this one, which is going to be null. Good. And then update the next to be this. Is that enough? What do you think? Are we done with this special case that my target is really the last node? Yes. Yeah, perfect. So we are also considering this special case, which is if I want to insert after, simply in this case, my value, the new node next will be null. So that's good because it will be the last node, and the tail now will not be the tail. So we are done, right? Good. So that's good. Any questions so far? Okay, good. So insert after value is done as well. So the last thing that I want to discuss before going to modify this to be a doubly linked list, Arjun, how do we create the final node when making the LL? So what do you mean by the final node, Arjun? Do you mean like the last node to make it null, right? So it's by default because initially everything is a null. So then the node with null, yes. So good. So let's look here. If I want to insert, so initially your head is initialized to whatever value you take in the constructor. If you have an empty list, this head would be null by default, right? And then you come and you insert at first, and your next would be null. So the only constraint you would have is to make sure your last node next is null, right? And this indicates the last node. And given our current structure, this happens by default because initially head is null, right? When we come to deletion, I guess your question will be more emphasized and we will discuss it. Because if you delete the last one, you need to make sure the one afterwards is, but let's see it, right? So if I want now to write a delete method, what should I do, right? Let me look into here. Yeah, you only create the, that's also a good question. Right now, the way we write it is you only create the list by insertion, or you already have a list and then you make the head pointing into it. This is also possible because, for example, you might have an already existing list and you make another reference to that list, right? Good. So let's look into the deletion method then. So I want to delete a node, and let's say, for example, I want to delete a node with a certain target value, right? So what I want is, first of all, void, and then like public void, but later I'm going to change this void thing, but let's keep it void for now, and then delete. Delete target, which means I need a target value to search, right? And then, given that now I'm dependent on the value, I need again to traverse the list for this value, right? So we can borrow the same code from here, making an index that you keep searching for a certain node, right? And then I'm making it head, while not, now I'm not find the node you want to delete instead of inserting after. If it is the case, then I should delete. And then keep this empty for now. And if I'm deleting, I'm done. And if not, I didn't find the target, so target not found, right? So the only thing you need to change here is, oh, and I don't need to create this new node. So that's not needed. So, oh, did I? Oh, come on. I changed the original one. Okay. Okay, because I have it big, so that's fine. So here, find the node you want to delete. And then if you find it, so you should delete here. And then we're going to write this code for now. And then if I didn't find it, I might print that I didn't find my target. Good. So the thing that we want to write right now is how would I delete, right? And that's also a tricky thing that you need to take care of. So let me go back to the visualization, assume that, let's remove all of this back again. Then assume I want to delete something in between. Again, I'm looking for the normal case, and then we'll look into the special cases. So I want to delete this one. Deleting it means removing the reference to it, right? But the problem is, if I remove the reference for this one to make it null, I lost everything afterwards. So I deleted everything, not just this one, right? So what I should do instead is, do you remember what should I do? I should make this one point to this one. So it's like bypassing the node that I want to delete, which means it doesn't have any reference right now, and then it would be deleted, right? So, well, now we have a problem, right? So what is the problem? I have my index. The index is starting from the head. Every time I advance it and I search for the target, right now, once I find my target, I want the one that is before it to point to the one that is after it. The one after it is simply index.next. So I have access to it. What about the one before it? Do you see the problem? Nicole, that's exactly correct, right? So you should search for the next one, not the one that you are in right now, because in a linked list, in a singly linked list, you never can look back. You don't have a pointer to the one that is your successor, right? So if you search only for the one you are in, assume this is the one that you want to delete, well, you'll not be able to delete because you cannot update the next of the previous one. So what I should do instead is to come here, and then instead of searching index.value, as you guys like, you are advanced, what you said is completely correct. I should search for the index.next.value, right? So why this would work? Going back here, right now, let's look into this example. I know sometimes my illustration is messy, but so this is my index. I'm not searching this one right now. I'm searching the one that is after. So I'm looking for this target, which means if the index is here, index.next is this one, and index.next.value is the target that I'm looking for. If that's the case, that means my index pointer or reference is directly before the node that I want to delete, right? If it's not clear, please ask, because I know that deletion is one of the tricky ones in linked list, right? So index.next is simply the one that is after you, and index.next.value is the value of the one that is after you, which means your index is still here, which means directly before the node you want to delete, right? So if that's the case, I need to delete. So how to delete is to do exactly what we said. Make the one that is before the one you want to delete, point to the one that is after. So, well, I know right now that the one that I want, the one that is before, the successor of the one that I want to delete, is pointed to by index. Updating its next to the one that is after. What would be the one that is after? Going back to the visualization, if this is index dot next, and this is index dot next, right? So I can write index dot next is equal to index dot next, right? So that's a way to write it. If this makes you confused, you can really, but it might not be a very, oh, did I do? It might not be a very efficient way of writing, but it's correct one. Define two indices, advance one always before the other one, right? And then search for this one, right? And then if you find the new index, the one that is advanced is targeting to the point, then you have the index to the one that is before it, right? That's one way of writing it if you wish, right? So one question to you that we discussed before, if I have done this, which is just removing the reference to the node that I want to delete, is that enough? Does that mean I deleted it? What do you think? Yes, right? And the reason that we mentioned is in Java, garbage collection by default. So deleting memory is much easier than C. In C, you have to free and do all this stuff. Here, you don't need to care. As far as you remove the reference, after some time, the garbage collector will delete the node for you, right? So here we deleted it. So what if we didn't find, well, what if we didn't find the node we are looking for? Then simply I'm not going to do anything. Are we done? Again, no. Why no? Because we didn't look into the special cases. What would be the special cases? What if I want to delete the node that is at the beginning? First of all, what if my list is empty? If your list is empty, you already considered it because initially your index will be null and you jump directly here. What if you only have, what if you want to delete the node that is at the head? Let's see if this works. I want to delete the head node. So in this case, my index, so let me go here to the visualization. Assume I have this linked list. This is my head. And really, my head has the target, right? So if I assign my index to be equal to the head, does this solve this special case? The way we write the code right now? What do you think? That's a tricky question. And that's one of the reasons why you should always check your special cases. So the way we write the code right now, does this solve this special case? So yes and how. So the question is, if my target is at the head as a special case, would this solve the problem? What would our current implementation of doing index to? No, it doesn't for sure. Yeah, now, thank you. Why it doesn't? Because I start my searching from index dot next dot value, right? So the first value I check is the one that is after the head, right? Does this make sense? So do you guys get that? So that's a special case you need to handle, given that the way you write the code right now. How to handle this is simply say, add another if. Well, yes, you can also add, yes, there are multiple ways of doing this, Nicole, thanks. We can really do multiple things. I would say the easiest way always to handle the head case or the special case is to have your special cases at the beginning, right? So always in all data structures, think in this way. And this is something you can do in exam, in interviews, in even big projects. First of all, try to follow that divide and conquer mentality, which is I'm not going to focus on special cases right now. I'm going only to focus on the normal case, which is I'm just deleting something in between. Good. Once you are done with it, you have the core of your code. After you are done, think of the special cases one by one, and you can really handle them even at the beginning as a separate piece of code. So the way I would prefer to do it is to say at the beginning, after I'm done my code, I'm going even to have something like this. This is the normal case. And then I might even write something for myself to say it also handles empty list, right? And then special case 1, target is at head, right? So if that's the case, how I would check it first, I would say if, as Nicola was saying, add as another head, I would check if head.value equal target, right? If that's the case, oh, I should have equal target. Then I need to see how to handle it, right? And let's think right now how to handle it. So if my target value is the head, well, how to get rid of the first node? What do you think? Going back here, how to get rid of this one? Again, the way to get rid of any node is to remove the pointer to it, right? So the way you can do it is to say, and by the way, you can write this as head or index, it doesn't really matter, right? And you might even define the index afterwards such that you don't have any node into this. And in this case, you would say head equal head.next. You removed the pointer and then you are done to just return, right? So you handle this special case at the beginning. If it exists, done, go ahead and leave, right? So it's easy. Are there other special cases? Let's check. What if I want, so we discussed the way you want to insert, to delete from the middle and from the beginning. It remains one, which is what if you want to, your target is the one that is as the tail or the last element, as Salah is saying. Perfect. So what we should do, let's check if our code already handles this. So we have a list. And my target happens to be at the last one, and this one is pointing to null. Well, if that's the case, my index would be here. Index.next.value will be the target. What I would do, as I would say, I would make index.next equal to index.next.next, so which means this one will be null, and then I'm done. Does this simply just solve the problem? What do you think? I'm just trying to apply our normal case code and see if it solves this special case, right? So index.next equal to index.next in the case of the last element would make this one to null, which will remove the pointer or the reference to the last one. Is this enough? Well, it is, right? Because as you look here, the new node would be this one. First of all, doesn't have any reference, so you can assume it will be deleted from the memory. And now this becomes your last, which means it should really point to null, right? So simply it just solves it, right? So which means I should also add a note for myself here saying it also handles deleting last element, right? Good. Questions? So I guess there was a question about return. So simply you can just return, which means you ignore the remaining of the function because it's void, so you just return nothing. But given that we are discussing this, a good programming practice is really not to return, especially for data structures, is not to make functions void. I guess I have already mentioned this before in C. The good programming practice is really make them bool, right? Like Boolean thing. And what would be the mentality of making functions return Boolean? It would be a way for you to check whether your operation has been done or not. For example, let's discuss as just one example case. If I make this pool, in this case, I'm going to check, did I do the deletion? Did I find it? So in this case, I would return true. And in this case also, I would return true. While if I come here, instead of printing something, or even along with printing something, I would say return false. Why this is something good? Why it's a good programming practice? What do you think? Any idea? Because printing isn't practical on larger scales. Yes, that's correct. It tells you what state you are at and how. That's also correct. To say it in a clearer way, when I use this class in other classes, for example, in the main, instead of just calling insert or delete function without knowing whether it happened or not, whether it found the value or not, I would take the value back in an if condition. For example, if it returns true, operation is done. If it returns false, then I know that the value is not there, right? So it gives you a handshaking for the caller method to know whether the method you called have really executed or has really executed what you are expecting or not, right? Yeah, yes, you land perfect. That's exactly what I was saying. Good. So Salah, when you are done, can you zoom out to show all the code? Just want to, yeah, sure. I even can share it with you on Avenue as well, right? There is no problem with that. Okay, so I know that we only have 1 minute remaining. One last thing to mention before, I thought it would take less time, but it's a good time investment. I believe I wasn't very happy about only discussing the theoretical last time, or only looking into to it in a slide. So that's good. So one last thing to discuss is, and I guess stopping at deletion will also help us discuss this. Deletion wasn't really very good for the single linked list because I needed to do this next or keep 2 pointers or do something that is very specific, right? And this introduces to us, what if I do something like this? This is my original linked list, and this is the head, and this is null, right? And instead of only having this, what if I have another link, not just to the successor, but also to the predecessor, right? So I have 2 links right now. Why that's something good? Because the deletion is a clear example. I have access to both before and after, so I can traverse the list in both directions, right? And this is called generally doubly linked list, or DLL, right? As compared to singly linked list. So doubly linked list, the only difference is instead of having a single link to the one that is after you, you have a link to the one that is after and the one that is before, right? How to do this is going to the code. It's very simple to change. I need to change my node to add another link here, and I would call it previous, right? It's as simple, and maybe I would also take this L node and then pre, for example, right? And then initialize previous to pre. By having this, I might write another class that, let's do this. I can call it dll.java, and then taking this one, DLL. Right now, it's not just you need the head. You can also, so that's something that is also good to discuss. Going back here, if I have this, simply you cannot just say the tail will point next to null, right? Because you need really 2 pointers, one that is going. So simply, if you look into any node right here, you find that there are 2 pointers to every node, right? Here, there is a single pointer or single reference to the tail. So what people usually do, there are multiple things that can be done. One thing is simply make either you define another tail, so this is going to be your tail pointer. And in this case, even the last one has 2 pointers. Or without confusing you, make this one instead of pointing to null, point here. And in this case, it's not a doubly linked list, it's a circular list, right? So that's a third data structure. But this is not our focus. So what we would do is we define another pointer or another reference. We have the head at the beginning, the tail at the end, and still the tail next will be null, right? So it's a terminated list. How to do this in the code? I have the LL node head and I have the LL node tail, right? And then simply initializing, you also need T and then say tail equal T. Good. So well, that's good. So let's say I guess I'm missing this here. Let's say I want to write my deletion just to give you. I know we are already over. Well, okay. So something you can do as an exercise is to take any of these methods, right? Like the deletion, for example, and try to write it for the doubly linked list. Again, this course 2SH is not a data structure course, so you will be revisiting really linked lists and even 2SI. But I guess it's a good application to what we have learned. So it's good to visit, but you don't need to know all the details about doubly linked lists. So if you think we have discussed this for 5 minutes, that's because it's not our focus. I just wanted to give you a taste of how we can play around with data structure from a single linked list to a doubly linked list. You will still be able to go through the example and write it yourself if you wish, right? By this, I should be done with the lecture, and let me see if there are questions for a few minutes. Thanks, everyone. So, question. So, Salah, when are you done? Okay. If you still want to have, I still want to have a void method, I always need return to terminate my method, right? So Yanhao, well, if you don't need to return in between, like within the code of the function, for example, going back here, I needed to return early something like this because I just wanted to skip everything. I wanted to skip the remaining of the loop and also the remaining of the method, right? So this is why I return it. If you don't need to do this, well, don't return, right? You will just hit this ending bracket and it will return by default. Nicole, okay, showing implementation of Java util linked list functions, right? Yeah, some of those functions, yes. I mean, the linked list class in Java has also some of these implementations as well. Yes, like calling the isAperTriangle method in constructor of the second class. Can I use other methods of the first class, like get element in the second class to make life easier? Yes, you can. Benjamin, assuming you made the fields of the first class private, I believe you would have to use get element. That's correct, Benjamin. Oh, I guess you were asking, you were answering yes, but yeah. Question. Muaz, can you post this example on Avenue? I will do so. Yeah. Katie, I can remember what you said about lab having one question that asks us to throw an exception in the lab, but not in the document. I don't throw an exception and passed. Yes, don't throw an exception, Katie. That's correct. So this is exactly what I said. Har Sahib, how many test cases do you have to do for the lab? One, the rule that is dictated in every single lab document is to write a single test case for every method. Yeah, you don't throw an exception like what? Yeah, you don't do this. But not, well, I don't want to confuse you. I guess like Katie was asking about specific method that I guess it was get element or set element, if I remember correctly. And set element just returns true or false whether you were able to set it or not. Yeah, it's Boolean, that's correct, which is applying exactly what we're discussing right now. It tells you whether the process has completed or not. So you don't need to throw an exception for this set method, but everything else you should throw the exception. So simply the thing is, here is the rule: follow the code structure that you have in the starter code, right? That's the rule. Don't confuse yourself. If the method has a throw exception in the title or the prototype of the function, then you should do so. If not, then don't do that. Are there any other questions related to the lab or today's lecture? Test case for toString, or is it fine that we call it another test case? Well, it's like Mark, by the way, writing a test case is really something that would take a couple of minutes, right? Especially you already have similar test cases. For example, toString, just change the toString testing method that we have in another string, and then it would be it, right? But again, it might be fine if you just call it in another test case. Nicole, you do it like this, right? Throw new exception error. Yeah, this is the template that we have in the method if we want to throw an exception. That's correct. Jack, can you zoom out so I can get the full delete target Boolean code? Yeah, sure.
Perfect, thank you.
Welcome, Jack. So Mark, there is no toString test case. What I remember is I have tested this toString, but well, yeah, maybe I'm mistaken. I don't remember, to be honest, but I believe I have tested it. But if not, then please test it. That's an easy thing, I guess, to do. Do we write this case for all the methods, just one or two for different classes? No, Julie, like, please read the instructions in the lab manual carefully. And we have had this for all the labs. Any method or function you write, you should test it in the test cases, right? That's the rule, right? So yes, you should add a test case for every method you write. And that's really like a 15-minute, 20-minute coding, because you already have the test cases written. What you need to do is only copy them and change the input, right? As we discussed in the very first lecture when we discussed the unit testing methodology, right? You need different input cases, right? I hope this clarifies if you have any concern. Are there any other related questions? Okay, so if not, then yeah, go ahead, Yanhao.
Yeah, like during the lecture, you were talking with the Arjun about, let me see, like there's a part you was talking about you letting pawn 1 go to new pawn, and then you
Correct.
let pawn 2 equal to pawn 1.
Correct.
I feels like, doesn't you just make 2 pawns exactly the same?
Yeah, both will be pointing to the same place. That's correct.
Yeah, so why you are doing that?
Well, one clear example is what we have here in the methods by making the index equal to head, right? And then move the index afterwards, right?
Mm-hmm.
So that's an application of making a reference equal to another reference, right? That's one use case, right?
1 second. I still don't get it. May you please make a...
Sure. Let me go here. Good. So assume I want to traverse the linked list, right? Where should I start? Well, the answer is you should start from the head, correct?
Mm-hmm.
How to do this? You need your index or iterator to first equal or point to the same place that the head is pointing to, right?
Mm-hmm.
Which is this index. How to do this is simply say LL node index. By this, I'm declaring a new reference to the LL node type, and then I make it equal to head, right?
Yes.
So that's an application of making a reference equal to another reference to point to the same place. And then later you can advance the other one, right? I guess your main question, Yanhao, was what would be the application of something like this, right? Why making two references to the same place, right?
Yeah.
Or was there? Yeah, so that's what I was saying is this is one use case because you start from here and then afterwards you advance if you wish, right?
Mm-hmm.
Does this make
So,
sense? Yeah.
so one is for the header, like to remember the head of linked list, and then another index is for traveling.
Exactly. Yeah.
Okay. I see. And can I just ask one more quick question regarding
Go
the
ahead.
lab? Like
Sure.
during the lab, you do the JUnit testing case, right? What I'm wondering about, like the reason why you add the JUnit by yourself is you just want the JUnit library,
Correct.
and then you delete delete whatever you.
Whatever template test case, because when you add G on it, it creates for you a template class for testing, but we already have our testing class, right? So this is why
whatever we need, just the library of the JUnit.
The library itself, that's correct. Yeah.
Okay. I see. Thank you.
Yeah, welcome. Okay, are there any other questions on the chat? Okay, so thanks everyone, and I guess I will see you all on Friday then. Bye-bye.